So I'm just going to get you started on this activity, and then I hope you can go through the instructions just to have a play with how regression works. So this is another app which I think is really helpful. I'm very grateful to the person who programmed this up. So you can change the axes, but I'm just going to, let's imagine we've got a scenario which goes from 1 or 0 up to 10. So I'm going to say, let's imagine the x-axis is the serves of fruit our participants eat each day, and y-axis is the serves of veggies. So I've started off by saying, imagine we've got 10 participants and they all eat between 1 to 5 serves of fruit a day, between 1 and 5. And then they eat a similar number of fruits and vegetables, between 1 to 5. So we could draw these dots on. And if you're not quite sure how to interpret a scatter plot, then I hope going through this exercise will help you interpret the scatter plot. So let's say our first person eats 1 serve of fruit and exactly 1 serve of veg a day. They would be there. And then perhaps our next person has 2 serves of fruit, but a little bit less for the veg, maybe 1.5 veg. They might go there. Then maybe we have someone who eats 3 serves of fruit and 3 serves of veg. And then maybe this person someone eats a little bit more veg than fruit. And maybe someone else eats a little bit more fruit than veg. We haven't got anyone up the 5 area. How many people have we got? 1, 2, 3, 4, 5. I've set it up to 5 serves of fruit and veg. 6, 7, 8. Oh, it's counting up the top. Cool. 9, 10. So I've got my 10 participants who are eating similar amounts of fruit and veg a day. So that should have a very strong correlation because I've drawn it that way. Display the line of best fit. Yep, very strong correlation, 0.94. So if you were drawing exactly 1 for 1, 2 for 2, 3 for 3 serves of fruit and veg, then you might have even got a correlation of 1 if you were drawing them in a really straight line. Obviously, you're very unlikely to get that in real life for a study, but this is about understanding how how it works. So you could calculate your R squared from that. Just by squaring it, and this would be if we wanted to predict how many vegetables someone eats based on the amount of fruit they eat, we could do it with this equation here. Now let's say we had one more participant in the study and he was really unusual. So although he ate 10 serves of fruit a day, he does not eat any vegetables because he does not like them. I've said 0, but I don't know if we can click on 0 on the graph. So 10 serves of fruit and no veggies. And you can see immediately that one person has had this really strong effect on the regression line. So that's why we check for outliers, because if you've got one unusual person, they can have a huge influence over this regression equation, especially in a small set of data. And so this would not be a valid regression equation for that in this case. And this might be a case where, although you can't ignore the fact that you had the person in your study, you could temporarily exclude them and say, for the rest of the people, this was the relationship. We had one outlier, and it would be worth repeating a study to see if this person is representative of part of the population. But let's imagine we had 20 people in the study, and the rest of the people are all following this pattern. So click in a few more people who are all following the original pattern. 20. So now that we've got 20 people in the study across the range of 1 to 10 all following this pattern, we can see that the outlier is having a lot less of an effect on the line. So the more people you have in the study, the less influence one particular outlier will have. But you'll notice that it's still having a pull on the line. So let's see if we can remove this point. Perfect. And you can see that the line now snaps back to the middle of the other points when we remove them. So that's just an illustration of the impact that an outlier can have on your data set. And then I've got a couple more activities there you can go through, seeing if you can understand exactly how this equation works, and if you can work out how to put points on a graph based on a hypothetical relationship.